arranged. Okay, so let's get started. Welcome everybody to the March Liverpool Manchester PWI Section meeting. Today we have. We're just going to keep coming in. That's fine. So today we have Paul Thomas who's the TRU Carbon Manager from Jacobs. We're working on TRU. Talking about the decarbonisation or reducing carbon on the PWI, in permanent way. Just go through a couple of the usual kind of introductions and the usual notices. So housekeeping, if we could all turn off our microphones and cameras. I'll be turning mine off shortly. No notifications today. We obviously had the conference at the start of the month. That was really successful. So again, thanks to everybody who turned up to that. No apologies apart from Dave Brooks, who can't be with us today. There are various things. Obviously, we're trying to get ahead of with the program for meetings, so that was circulating in these section invites, and we'll kind of keep that up to date so everyone's fully aware of the meetings that are coming up. If you do want to present, we just had somebody offer to present, then get in touch with myself or David Woods, and that would be much appreciated. We have got some slots towards the end of the year, so there's no rush. This admitting thing is really annoying, isn't it? Yeah, any questions? If you want to ask any questions, put them in the chat. That'd be really useful, and then we can just kind of address them at the end. If that's okay with you, Paul?
Yeah, that's fine. I can't see the questions as I'm presenting with the presenter mode on PowerPoint, but yeah, I'll pick them up at the end for sure.
Yeah, we'll go through those at the end. And then we'll just kind of touch base at the end and go through any other business. So without further ado, Paul, I'll hand over to you, and yeah, you can take over. I'll just switch off my camera. Off you go.
Okay, thanks very much, Richard. Yeah, afternoon everyone. Thanks very much for having me on today. So, as Richard says, I am carbon manager on TRU. I've been in that position since October time. So, essentially onto common to Network Rail. So I work for Jacobs, normally based out of the office in Birmingham. So I'm a principal sustainability professional with Jacobs. Been with them for about 2.5 years now. So my remit and my background is kind of in wider sustainability. So on top of carbon, I'm looking at all the other aspects around kind of sustainability strategy and development, assurance, and then, wider aspects around biodiversity, circular economy and that type of thing. But today we're going to have a look at the work we're doing on carbon on TRU. So carbon and kind of the wider sustainability piece, just to kind of give everyone a bit of context and a bit of background about kind of what we're doing and where we're taking the program. It is in a state of flux slightly at the moment. We've had a new head of sustainability on the team, and we're looking to kind of expand our remit a little bit, which I'll explain in a little bit more detail as we go through. But yeah, essentially we're looking at some points here. So looking at the kind of wider sustainability piece, looking at what we do as a program team in terms of carbon and sustainability, and then looking a little bit in detail at track, and then some key questions at the end. So I'm not an engineer, so I'm sure everyone here has a far greater understanding of track and engineering elements than I do, but obviously I'll give us a take from the carbon side. So first things first, what is transpennine route upgrade or TRU? So I appreciate that some of you on the call may well actually be working on the program, others from obviously involved in railway, potentially in other areas. So just as a high level overview, I thought it's sensible to kind of start out as to where we are with the program and kind of what the aims of it are. So essentially, it's an upgrade of the railway between Manchester and York via Leeds, highlighted in red on this map here, obviously through a number of other intermediate stations. And the idea is it's a transformative programme that's going to improve connectivity in the north. So it's going to provide more reliable services, more frequency, more seats and faster journeys. And I believe it was started. I mean, I started on the program in October, but I think the program's been running essentially for at least 5 years prior to that through the various different planning stages. And we're starting some build elements at the moment with sort of preparatory works and things on certain elements of the program, most notably in the east. So essentially, it's divided into two: east of Leeds and west of Leeds. Each of those projects is being delivered by an alliance of contractors. And I sit in the program team, so we essentially represent Network Rail, and we have the oversight of what's happening on both east and west. But we're in the sort of the assurance and strategy areas rather than the delivery. So as I say, work is kind of started. There's obviously things going on in terms of diversionary routes and kind of a lot of preparatory works, compounds, and that type of thing. So the first project that's going to be completed is Project East 1, which runs from York, and the idea is that is going to be targeting completion in early 2027, with other programs and projects going to go towards completion towards 2030. So obviously is a fairly long-term program, and obviously a vast amount of work going into that. So moving from what Transpennine Route Upgrade is to kind of why we're looking at sustainability carbon, why are we looking at that as part of the program. So as everyone I'm sure is aware, there are a number of drivers for these agenda items, from international agreements like the Paris Agreement from 2015, and then you have filtering down to national levels of legislation regulation. So the UK government was the first to legislate for net zero carbon in our economy, which is due by 2050. And that had been tightened up from an 85% carbon reduction in the Paris Agreement through to the net zero. So we're quite innovative in that sense. But all other nations and levels of authority from national down to regional are kind of moving in that general direction. And as we can see, kind of the impacts of man-made climate change are only getting worse over time. Obviously, it's rare that you have a week or two that goes past without some reference to extreme weather events, be it droughts, floods, whatever it may be. So as part of that is obviously all around reducing emissions. As we can see on the right-hand side of this slide, the importance of transport emissions. So this graph looks at the last 30 years in terms of emissions in the UK. That's running up to 2018. And as you can see, that blue line there is the energy production, and obviously the emissions from that have fallen dramatically since 1990, and the reason for that mainly is the reduction in use of coal. Obviously a vast increase in the amount of renewables, specifically and most notably wind power, offshore wind power, and solar to a certain degree. So energy is now dipped below transport in terms of being the most energy intensive, emissions intensive activity in the UK. So transport is now the most carbon intensive and activity that happens in terms of the area of the economy. So obviously something that needs fairly serious addressing. So take it down a level now into the railway. As you can see from a few graphics on here, specifically the one on the right hand side there with the blue bars, a typical rail journey is far less carbon intense than flying, but also than traveling by personal vehicle. So a modal shift towards trains is obviously going to be a benefit in terms of addressing climate change, and especially when we're also moving towards electrification of the railway as well. So moving away from diesel to renewable energy, well, for electricity, but specifically also with that greening of the grid, more and more renewable energy in terms of driving those trains. And as we can see from that little graphic in the middle there, rail actually has a relatively small capture of the freight market. So again, looking at moving freight onto rail is going to have a massive benefit in terms of emissions, especially seeing as trucks have a far greater emissions impact than personal vehicles. So the idea of all of this is essentially shifting from road to rail and the associated environmental benefits of that. So Network Rail are well aware of this, and they have recently released a new environmental strategy, which I'm sure many of you may be aware of. which is all around their ambitions for a low emission railway. So carbon being an absolutely kind of crucial pillar of that new strategy. And what they're trying to do is align with, as all industries are, align with those government targets of moving towards net zero by 2050. So you can see on the bottom left-hand side of this screen what their journey is planned to be. So between now and 2050 for the various different control periods, and then looking at their different amount of reduction they're trying to target during each control period. And I've highlighted in red that box there, how that's going to roughly align with how TRU, the program of TRU is going to develop between now and 2030. So a little bit more detail. Network Rail obviously is an organisation, so many of you may well be familiar with carbon scopes. So scopes of emissions. So scope 1 emissions are emissions created when your organisation or program is directly burning fuels, so things like burning petrol in cars, gas, etc. Scope 2 emissions are around the emissions associated with electricity that organisation use. And scope 3 emissions are your other indirect emissions, of which there are a number of categories. And as you can see in the top right hand side of this screen here, these are Network Rail's estimations. They are only estimations, but they're estimations of where they think their scope 3 emissions lie. And as a rule of thumb, scope 3 emissions are going to be far, far more than your scope 1 and 2 emissions. And the reason for that is it's everything to do with how your organisation interacts with the wider environment, but that you don't control. So as we can see here, the main areas around kind of those purchased goods and services and capital goods, so things that Network Rail are buying in order to complete railway builds and upgrades and that type of thing. So again, TRU would fall under this category because obviously we're buying a vast amount of goods and services in order to make TRU a reality. So we kind of fall into that category of scope 3 for Network Rail, but that is obviously one of the more difficult areas to decarbonise from a Network Rail point of view, because they don't have direct influence over the different elements that kind of make up those areas. So there's a business case for TRU, which has had a number of iterations, and we're currently on the program business case, following on from the outline business case. This is actually going through a review at the moment for a second program business case, but as it stands, I've pulled out a few statistics from here. Just to give a kind of an idea about what the impacts of TRU are going to be from an environmental perspective. So the environmental case, obviously alongside the economic case, is one of the key pillars for how we're going to justify the build. Obviously it aligns with the Build Back Greener, the kind of the post-COVID agenda from the government, and obviously again aligning with those net zero ambitions for 2050. But just a little table I pulled out there just to give an idea about the level of impact. So there have been a number of different iterations in terms of the options and the option selection for TRU, precisely what's going to be built and where. We are currently on option F1 and moving towards something called option G, which is our next and likely final option. And option G essentially has come about through the integration of TRU with Northern Powerhouse Rail, which is all part of the integrated rail plan, which was released back in January. So this essentially adds some extra elements onto TRU that weren't there previously, some sort of integration with wider rail infrastructure in the north, and specifically a focus on trying to shift more freight onto the railway than was previously envisaged, because at present most of the freight from the sort of Liverpool area going east tends to go by road on the M62 for various different reasons. The railway doesn't have the capabilities to carry that much freight at the moment, partly because of I think tunnel sizing is one of the issues with not being big enough for containers, but there are a number of other things that need to be upgraded. So essentially we're moving towards option G, and we're kind of working out as a program how we do that at the moment. But as you can see from that table, kind of gives an indication of the amount of carbon emissions going to be saved by these programs, by these options. Sorry, so partly due to modal shifts, so that's getting people out of their cars and into the railway, but and also obviously similarly for freight, getting freight off trucks and onto the railway, but also because of electrification. So you can see the change in emissions numbers due to the options here. Essentially, option C has limited electrification in a nutshell, where option F, F1 and G are full electrification of the line, which is the preferred option at the moment. And obviously, you can see the massive impact that has, moving away from diesel train sets to electric with overhead lines makes an absolutely massive difference. So there's just some interesting kind of statistics there, and we're looking initially at, I've done some outline work in terms of grip 3 with what the total emissions are of the build of TRU, and we're looking at somewhere in the region of 500,000 tonnes of carbon. As you can see, we're looking at there. Option G, we're looking at nearly 100,000 tonnes of carbon saved per year through the build. So obviously that, from a carbon debt perspective, that gets paid back very quickly with option G. So within 5 years, we're having net carbon benefit, and the lifespan, well, I think we use it for carbon purposes. We're using a project and program lifespan of 60 years, but obviously it's probably likely to be around for even longer than that. So obviously the benefits over time there of those reduction emissions are absolutely massive. In addition, there are some other benefits as well to touch on. So looking at reduction in noise, obviously electric trains over diesel trains, and a reduction in traffic and an associated air quality as well. So again, removing trucks and cars from the road and removing diesel train sets is not just the carbon that's saved, it's the particulates, NOx and SOx and so forth. So overall, massive benefits from an environmental point of view of doing this program. So as a program sustainability team, of which carbon is an element, we are tasked with delivering that business case essentially. But that business case, what that states is what the impacts are going to be of having built the program. We're also trying to look at how we minimize environmental impact and maximize environmental benefit during that build. So this table just gives an example of some of the things that we're looking at. So you've got your drivers on the left-hand side there. So that's your regulation and your legislation from government, but also from Network Rail. And then in the middle, highlighted is what we're attempting to pursue. So it's not just carbon; it's looking at a variety of different sustainability aspects. So net positive biodiversity, looking to deliver a 10% gain in biodiversity over the course of the program. Looking at where we source our materials from, ensuring we're maximising resource efficiency, and then a lot of aspects around the social side. So ensuring that we're constructing the scheme in a caring manner, and obviously a friendly manner to our neighbours along the line side there, but also building accessible infrastructure, and a big focus on STEM and ensuring kind of local employment, internships, things of that nature, working closely with local schools and colleges. And also extremely important, the fifth one down in the list there is around delivering weather and climate resilient railway essentially. So there's a weather and climate resilience plan that has been just the second draft of which is being drafted at the moment, which obviously focuses on ensuring that the railways is resilient to those extreme weather events, which, as I said, are becoming more and more common. So some advantages on the right hand side, just to give you a flavour of kind of the work areas that we're doing. And as I say, as a program team, we aren't delivering these directly, but we are setting the strategy, setting the KPIs and targets, and working closely with the alliances to ensure that they are being delivered. So having a think about rail and carbon, which is kind of one aspect, obviously, of that wider environmental benefits that we're looking at. So we're not certified to, but we follow the PAS 2080 carbon infrastructure standard. So this looks at the impacts of carbon across the whole life cycle of a program, and this is the typical graphic that you tend to see when discussing PAS 2080. So essentially it breaks the life cycle down into a number of modules. So you've got the before use, during use, and an end of life stage. So when we're measuring carbon on the program, we want to be taking all of these into account for every single aspect that we're doing. You'll tend to find the major impacts around modules A1, A2, and A3 there. So that's looking at materials, essentially, sometimes known as capital carbon or embodied carbon. And that gets your raw materials out of the ground, transported and manufactured and to site. Well, and manufactured and then transport to site is actually module A4. So that tends to be one of the most carbon intensive carbon intensive areas, but we're also taking into account how that then moves from the manufacturing facility to site, which is A4 there, what energy you're using during construction. So are you burning diesel, gas oil in your excavators and in your trucks and so forth, and then looking at how the railway is going to operate. So at the moment, we don't take traction energy into account in terms of our calculations, though that's something we're going to be looking at working with the train operators on a little bit more detail to kind of link into some of those benefits I was showing on the previous slide. But what we are looking at is energy used in other areas. So that might be lighting, telecom, signaling, that type of thing. So obviously that has a carbon impact through use of electricity or other fuels, and that needs to be taken into account as well. And then the replacement, maintenance and repair are crucial. And I'll come on to that a little bit later in terms of what those kind of impacts can look like. And also at the end of an asset's life, obviously has to be deconstructed, transported away, and then disposed of. So there are usually emissions associated with that aspect as well. So all of this needs to be taken into account when we're setting targets and we're looking at what the carbon impacts are of any particular decisions. So we have set some targets for our alliances. We set a target from a GRIP 4 baseline. So GRIP 4 single option design. So the alliances then know what they're going to build, and they can set a baseline at GRIP 4 because they have detailed information about what that's going to look like. And then they can we require them to set a target to detailed design at GRIP 5, and then a further target to delivery at GRIP 7. So the targets are up there. We have minimum targets of 4% reduction to GRIP 5 and 12% to GRIP 7. And then some stretch targets as well, obviously, which are in excess of that. So at the moment, we're in the process of essentially gathering that baseline at GRIP 4. And our first project that I was saying, project E1, that's going to be delivered in 2027, has just delivered their savings for their detailed design at GRIP 5, and they're in excess of their stretch targets. They're looking more like sort of an 8% saving at the moment, which is great. And obviously, we're hopeful that the innovations on that project are then going to be spread across the route, and we can kind of capture those and further ones as further savings as we go forward. I'll just have a little explanation about how we do this. We use something called the Rail Carbon tool, which is a mandated network rail tool. A little snapshot here you can see from Leeds Central. So, which is this is basically the upgrade of the Leeds station, which is kind of is part of TRU, but slightly separate in terms of the carbon strategy. But just gives an idea about some of the numbers in there. So you can see this highlights the product stage. So as I was talking about in that previous 2 slides ago around the different modules, this looks at what the different emissions numbers are for the different types of work that's been going on here. So you can see you've got some numbers, kilograms of carbon emitted for things like earthworks and ballast and that type of thing. But essentially all the calculations take place in this tool. This tool looks at predominantly at this product stage, which is highlighted here, i.e. the main impacts around materials and also kind of transport to site and that type of thing. It's not a perfect tool by any stretch of the imagination. There is other work that needs to be done outside of this in order to get a whole life cycle approach. So looking at things like the transport, the energy use within assets and the decommissioning and that type of thing. So there are limitations, but this is the tool that's kind of been mandated at the moment. But there is actually talk of, well, we are actually working on moving to something slightly more advanced and trying to unblock some of the key issues. And the key issue we tend to have with this tool is that it's delivered by carbon specialists on the alliances, and in order for them to do their work, they need to extract the various different items of data around things like quantities of materials and that type of thing from engineers and designers, and obviously those people are, such as yourselves no doubt, are very busy, and therefore sorry, bear me 1 second. Sorry, I do apologize. 1 second.
Just a quick dog break. Just won't be a few seconds.
Sorry, everyone. Parents of homeworking. I do apologise. So yeah, extracting data from the designers and engineers and things can be a bit difficult. So the next stage around kind of evolution of carbon tools is moving to something in real time. So this is just a screenshot here of a tool that's being developed by Jacobs and Network Rail at the moment, which basically looks at using the data that already exists in the building information management models, so the BIM models, that kind of digital twin of the program, and allocating and incorporating carbon within that. So the designers and engineers, when they're looking at how to build the railway, we have that information to hand straight away. So rather than it being a laborious process of kind of toing and froing between engineers and carbon specialists, the engineers and designers can see exactly what's going on in terms of carbon with every decision that gets made, and we can therefore see the impacts of these different decisions and help them guide them in terms of what lower carbon opportunities might exist. So this tool has been developed by us at the moment. We've got other tools with similar kind of purposes which are being developed by the alliances, the different kind of construction and consultant partners on each alliance. Obviously, each has their own tool, slightly different purpose, but essentially the overall aim is to speed the process up and allow designers to kind of make those decisions in terms of carbon and take that responsibility, because at the end of the day, they're the ones that have the most influence. So it's quite an exciting development. I think that's somewhere where the industry is definitely going to be moving, because it just makes the whole process that much more efficient and puts the kind of responsibility and ownership in the right place. So a little bit of talk on the way kind of carbon impacts on a project. So we have the kind of carbon reduction curve here on the left hand side, and it just shows what the impacts are over time. So obviously the earlier you are in a project, the quicker the easier it is in order to affect carbon. So as you can see, I've kind of aligned the carbon reduction curve with the grip stages here, just to give an idea about the level of impact. Obviously things around planning and design, you're making large decisions and large changes. Should we put in a bridge here? Is this better to be a viaduct or an embankment? These type of things. And obviously each of those decisions are going to have a massive carbon impact. Once you get to your single design option and you're finessing that design, you have a lower impact essentially, because those decisions are going to be dealing with materials and energy decisions at a kind of more granular level. And again, as you're working your way through the actual build, again, the ability to influence becomes even less. So it's important to have an understanding of what the carbon impact of your decisions are at that early stage. And obviously, as per the previous slide, those kind of real-time tools make that a reality and make life a lot easier, and obviously will facilitate lower carbon options over time. And the image on the right there is the carbon reduction hierarchy. So this is from the infrastructure carbon review, I think from about 2016. But these essentially set the principles of how you deal with carbon. So obviously the first piece is around building nothing. So the way to get zero carbon emissions is not to do anything. That's point one. Point two is, if you have to do something, which obviously under normal circumstances you do, we have to look at how you minimise the amount you build. Can you reuse anything that's already on site, for example? And then you're moving into kind of build clever and build efficiently. So you're looking at new technologies, and then obviously that focus around resource efficiency. It's a snapshot here from one of the projects. I think this is W3, just looking at the different elements that make up the project, and kind of a hot spotting around the carbon. As you can see, track at the top there is always one of the high carbon emitters, and anything with kind of the kind of key materials in there, so steel, concrete, shifting large volumes of aggregate, that type of stuff is always going to have a large carbon impact. So those the areas that tend to kind of pop out with those major hotspots. And again, something's definitely worth thinking about here, just thinking back to the PAS 2080 module. So it's not just the initial kind of install and the initial build that has a carbon impact. Obviously, the number of times you have to replace a certain asset is going to have a massive impact as well. So as you can see as an example here, looking at the it's not so much the maintenance and repair, but it's the replacement aspect. So if you're replacing, say, sleepers 2 or 3 times over the lifespan of a program, obviously that's 2 or 3 times what you did in the first product stage. So longevity of asset and durability of material is really, really important in terms of reducing that amount of carbon impact. So again, it comes back to that, build nothing, build less. So if you can use less materials, you're going to have a much lower carbon impact. So something that's worth thinking about in terms of when what carbon, what materials are selected. So it might be worth actually thinking, well, this particular material is costs more financially, and there might be a slightly higher carbon impact up front, but it's going to last twice as long as the other option, and therefore overall is going to have a lower carbon footprint. So that's why it's very important to think about things in the round and that whole life piece, not just specific elements or just what happens up front. And I guess it's the same with costings as well. It's the capital cost versus the lifetime cost and the operational cost of a program, which obviously need to be taken into consideration in order to get that full picture and ensure value for money, or in this case as little carbon as possible. Okay, so looking I suppose just touching on track here, and as I say, I'm sure you on the call know far more about track than I do, but that is one of the largest impacts for us on TRU we're finding initially, because unlike other major programs, say for example like HS2 or programs that are building from kind of greenfield or from scratch, we're replacing, and essentially this is a replacement and an upgrade program. So yes, there are some areas of where we're building fresh in terms of we might be going from 2-track to 4 or something along those lines, but essentially a lot of the work is around track replacement. And because track contains 2 of the most carbon intensive materials, that being steel and concrete in terms of the sleepers, that means that we have a kind of a disproportionate amount of the footprint which falls in the track category. So it's a question of what can we do in order to reduce those impacts, and we are limited, I guess, to a certain degree around the standards set by Network Rail. So before coming onto this program, I didn't realise that Network Rail, for example, had a maximum of, I think it's 10% recycled content within rails, and moving from virgin steel to recycled steel has a massive carbon reduction opportunity. And obviously, if you're limited by not being able to do that, that limits your carbon reduction opportunities in that particular area. And I know there's a number of different activities that are taking place in terms of looking at these things for track. So what specific things around sleepers? I know there's composite sleepers that have just been deployed down at I think there's a viaduct down in Wiltshire somewhere, which is essentially their replacements for wooden sleepers rather than replacements for concrete. And again, I think that's due to the the speed limits that are on those particular sleepers. And obviously, one of the aims of TRU is an upgrade in the speed of the line in many places, in which case they're not appropriate. But there may well be other opportunities. Things around low cement concrete is crucial. So looking at using PFA, pulverized fuel ash from power stations, essentially to reduce the cement content of the concrete. So that's a crucial area. And something else we're having a look at on TRU, though probably not in the sleeper sense, is something called concretine, which is essentially graphene laced concrete, which has a remarkably reduced carbon footprint, predominantly because of the strength using the graphene means you actually use less concrete. That's probably unlikely to be sleepers, but maybe concrete in another area. But again, these are kind of innovations and trials that we want to kind of push on with in order to kind of demonstrate the viability of these technologies. So I'd be interested if anyone has thoughts as to how carbon reduction might take place in track, and any other innovations that we're not aware of on the program would be interesting to discuss. So you can see here I've taken this from another Network Rail presentation, but just to give an idea about where the main carbon emissions lie from any kind of track renewal. Obviously around rail is absolutely massive, and then concrete sleepers being the second item on there. So between those two, you're looking at 2/3 of the emissions for any single piece of replacement, and various other things happening on there as well, but ballast as well being a factor. But those two, rail, steel and concrete, always come to the top in terms of any sort of carbon discussion, be it on rail infrastructure or any other wider infrastructure programs that I've worked on in the energy or the defence sector or anywhere else. Just a few examples of stuff that we are doing. This is a slightly older one now, but essentially using a geotextile kind of expanded honeycomb panel. Again, filling with granular material, and just the idea around this around reducing fill. Again, just thinking back to that kind of build better, build less aspect. So using less materials to solve a problem essentially, and obviously anything to do that, you're going to reduce your carbon footprint. There are various other things we are looking at or have implemented. So under sleeper pads is another thing in terms of track, so that's reducing carbon impact by up to 30%. Reusing what's already on site, trying to link in with some of the other work that Networks Rail is doing, which can be a bit tricky sometimes because it's such a massive organisation, but there is actually a circular economy kind of reuse and recycle program within Network Rail called Surplus, where they do a lot of kind of refurbishment and remanufacturing of items, including things like points, so that can be kind of reused elsewhere on the railway. As I said, cement replacement, looking at anything to taking cement out of concrete, and there's a variety of different companies, Tarmac and all the major players are looking kind of into this as well, so we're keen to kind of trial as much as we can. Simple stuff like trough, so that's recycled plastic troughing rather than using kind of concrete for laying cables, much lighter, and again recycled, so you're reusing materials during that process. And the last point on their design changes, so again coming back to that initial point around in kind of enabling the design teams to have an impact and understand what that impact is in terms of carbon. So we have I guess touch on this kind of the process that we work. So the alliances run a number of workshops on the scheme. So working with the design and engineering teams to kind of look at ideas in the initial design phases around resource efficiency and designing out carbon. Both alliances run value engineering logs, so that's ideas from anyone. Can be on cost savings or kind of sustainability benefits as well, both for carbon and kind of wider benefits in terms of waste, recycling, biodiversity, whatever it might be. And they're all captured and evaluated in order to identify any ideas that should be taken forward on the programme. And the idea, of course, with this is that when one alliance identifies something that's worked positively for them, it's then shared amongst the group. And we do have a very good working relationship between the two alliances and ourselves as a programme team. So, for example, we have that every discipline has a 4-weekly kind of forum. So I have a carbon forum with both alliances, and we can kind of discuss best practice and these types of things that they've tried and kind of share across both alliances, which works really, really well. So yeah, our role is around supporting with knowledge share, and also pulling in that expertise, I suppose, from other programs as well. So having myself worked on HS2 and a variety of other colleagues from Jacobs have worked on HS2 and other rail and highways projects, and again ideas from other industries as well. So be that through the water industry, energy, Ministry of Defence, whatever it might be. So there are a few things on here just in terms of what the impacts and blockers are, because again, on any big program, it can be difficult to get new ideas off the ground. So we just kind of put this together, and I've actually presented it to our engineering team 2 or 3 weeks ago, just to kind of give them a guide about what the blockers have traditionally been and potentially some ways around it. I think it's always important to be gauging the kind of senior leadership on this, and actually carbon has become a massive hot topic on the programme of late, and it's got a lot of buy-in from both the senior management and the kind of the heads of engineering. So we're seeing probably more traction on the programme in terms of carbon than we did probably over the last 2 or 3 years combined. So that's really, really positive. And lastly, I'll just kind of wrap up with this slide, which is just around the way innovation works, I suppose, and just kind of highlight the fact that you need to start now, essentially. So innovative products and ideas can take a long time to become normal practice. So schemes like TRU, HS2, these big infrastructure schemes have kind of an ability to kind of legitimize some of these new innovations and technologies, things like your concretine or any other kind of materials innovations or processes. It gives a test bed for those. It proves that it works on a large, well-known infrastructure scheme. It can really kind of drive those technologies forward into the mainstream. So we're very keen to ensure that happens on TRU. It can be tricky sometimes, but again, as I say, if there's any other work and innovations that you're aware of and you're working on in other schemes and Network Rail, we're very keen to hear them, because sometimes those communication channels can become a bit blocked. So again, this is just a good opportunity to kind of have a discussion on some of those topics. And again, I'm happy to listen to any kind of feedback that you might have, or any ideas. We'd be more than welcome. That'd be great. So just in summary, just in terms of what we're doing on TRU, the main important point, so early intervention gets better results. So again, looking at those decisions as early on in the programme life cycle as possible. We're looking at whole life carbon, again, not just looking at materials or just looking at energy. You need to look at carbon in the round in order to make the most informed decisions you possibly can. New tools are being developed, so we're moving, although we'll keep the rail carbon tool, what we want to do is kind of use these more to kind of digital technologies and digital twins and that type of thing to enable much faster decision making. And again, the quicker you make a decision, the more likely you are to have a carbon impact. There has been a lot of good work done and a lot of innovations have been taken forward on these initial projects. We are limited by the fact that track replacement is kind of the main focus. So things that we have done are kind of marginal gains, I suppose. So I don't doubt that there's some significant opportunities for improvement that are still out there. And also kind of the point, I think, as what we're trying to do across the alliances and program management team is to enable everyone to contribute. So things like the value engineering logs, ideas and forward carbon forums and that type of stuff. There are, we don't have all the answers, and obviously keen to kind of embrace as much as we can from experts and engineers and designers and people from across all the alliances, just to chip in and ensure that we're kind of moving in the right direction and reducing carbon as much as we possibly can on the program. So that pretty much wraps it up, I think. Happy to take any further comments or questions.
Right, okay, let's see what we've got. Not a lot of questions, so clearly a very thorough presentation. So thanks.
Maybe, yeah.
Thanks for that, Paul. So Dave Woods is just asking, are you happy to colleagues to share ideas with you directly within TRU or outside? Which I think you've touched upon.
Yeah, definitely. I mean, I know Dave's got my contact details, so yeah, by all means, come to me in the first instance. I can share contact details of. I mean, so if you tell me you may be working on the program, the heads of sustainability for the different alliances. So a chap, Simon James on Volker Rail on East, and then Mike from Amy on West. I'm happy to do that, or feel free to reach out to me directly by all means.
Okay. And Stuart Corrie is asking, how can NR realistically predict carbon usage reductions as they don't have control over modal shift? So I guess that would be carbon usage in the actual transportation, or is that talking around construction, Stuart?
I mean, I was thinking operation, because it obviously makes sense to invest carbon today if you can significantly reduce the in operation costs in operation carbon.
Yep.
And shifting people from car to train is obviously great. But how on earth do you make those decisions? You don't have control over them.
As in, how do you get people to shift to shift?
Yeah. Well, not just that. It's how do you get a sensible answer on the amount of carbon that you're using on a scheme if one of the biggest things that's going to occur on it is the reduction in use of cars.
Oh, I see.
Yeah. I mean, I suppose there's a couple of facets. I mean, taking a kind of a step back from carbon. I mean, I suppose just thinking at TRU. So the kind of the initial aim of TRU was to deliver kind of the other benefits as well. So the economic benefits around, faster, more reliable journeys, more seats, that type of thing. So the kind of driver for the program, I suppose, is that in the main. And then I guess all these other elements are evaluated as part of the business case, and looking at all the traffic modelling about how, what the likely impact is going to be, how many people are going to shift from one mode to the other. Sorry, I'm kind of losing my train of thought here. So I guess that's the main driver. You're not necessarily building the program on the basis of carbon savings alone. I guess that would be the kind of the main issue there. And obviously there's various different traffic modelling that takes place to kind of work out what the likely impacts are going to be. And I guess the idea, if these schemes are then going to be built anyway, the economic case is that it's sensible to build this scheme for those particular reasons, i.e., the increase, journey, reduction in journey times and that type of thing. Our job is to then ensure that we are delivering that in as an environmentally friendly way as we can, i.e., reducing carbon during the build. So that's a kind of a key element, I think.
Okay, thanks.
Yeah, excellent. Rob, you have a question?
Well, I'd asked the question, but just to follow on from that, I think the key thing is that there was an article in one of the magazines a few months ago suggesting that environmental benefits of rail were fairly low down people's priorities when they were choosing transport mode. It was more about value for money and reliability and punctuality. So I guess the challenge is to provide a more attractive service through the TRU and get the benefit from the carbon from the transfer by providing a more attractive service. But yeah, my follow-up question that I put in the chat was there was also an article I was reading about high-speed 2 trialing different types of fuels in their construction plant. Is that being transferred across to the TRU?
Yeah, so I think they're targeting a diesel-free construction site by something like 2027 or something. Yes, it is. That's the first stage. That normally happens moving from diesel is to something to HVO, hydrogenated vegetable oil, because of reduction in kind of particulates and things associated with that. But which is fine. I think technology is moving in that direction anyway. So the electrification of construction plant is underway. It's not as visible as things like personal vehicles, but most major plant manufacturers are developing or have developed things like electric, be that trucks or earth movers, that type of thing. So I was working, Jacobs are working on the Thames Tideway project down in London, where they've had the first electric hydro phrase, which is a massive drilling rig essentially, and it's kind of the first in the world kind of piece of kit which they've been using for the last couple of years, and then obviously normally that's built on diesel. So generally the industry is moving in that direction, and I think HVO tends to be the first kind of step in that direction. I'm always slightly reticent with these things around biofuels in terms of they need to know the provenance of them, because if it's come from things like waste food or whatever, that's absolutely fine because it's a waste product. If you'll start using energy crops and shipping stuff from other parts of the world, obviously I'd question the carbon impact of that. So I think again it's one of those things where we need to look at it from a whole life cycle perspective. But in terms of other things TRU are doing, there's a lot of a move towards electric use of electric vans instead of diesel vans, and also things like solar and hybrid generators rather than diesel generators. So that's something that the guys on East have been doing for a little while now and has had a big benefit in terms of reducing diesel.
Very good, very good. A lot of the tools are becoming electric as well, aren't they? The traditional kind of petrol-driven tools, which feeds into your comment about the neighbourhood sustainability and reducing noise and all that kind of.
Yeah, electric hand tools is something we were just discussing a couple of weeks ago. Yeah, so the guys on East, so yeah, led by Volker Rail, everything's moved to electric hand tools now. So as you say, that's a kind of one of the easier things to do, I suppose, in terms of the smaller the scale, the easier these things are to electrify versus some of these big bits of plant. But again, that is also happening.
Excellent. Okay, any more questions? Final call. As we mentioned at the beginning, this has been recorded, so if you are interested in looking back, you can get it through with your website, PWI website, if you're a member. So if you think it's of any interest to anyone else, then please let them know. No other notices for us. In fact, I don't even have to hand. This is poor preparation of the next meeting. If anyone's got that to hand, that'd be really useful. But the next meeting will be held on the 21st of April online. Dave, yes. Do you have it?
Okay, hopefully I won't coffee you. So this is, I think we've got the route engineer, Matt Shelton, and Ian Fox presenting on drainage on on Eastern and some of the initiatives they've been looking at and innovations. So I think it's probably tying in with what Paul's been talking around today as well, from a climate change perspective.
Excellent. Thank you for that. Thanks for filling in. So as I say, that will be on the 21st of April at 1 o'clock online. And we will look to kind of try and get a hybrid meeting at this side of the summer break. So keep your eyes peeled for that. Obviously in Manchester. And if there's anything else you need regarding the PWI, drop myself or the secretary an email. And if we could all just do a traditional PWI thank you and unmute your mics and join together in a round of applause for Paul as a way of thanks, that would be great. Thanks a lot, Paul.
Pleasure. Yeah, thanks. Sorry about the interruption halfway through.
Oh, that's fine.
Typical.
All right, round of applause. Thank you.
Cool, thanks.